Hello, welcome. This is going to be lesson V8, and it's going to be about the absolute value inequalities. And one of the things that you need to remember is this property here. If you have the absolute value less or equal to a number, you're going to change into an AND statement like this right here. So if you ever see this symbol, you're going to change into this. Okay, so let's look at these examples right here. Okay, I have n minus 6 less than 2, so according to this, if I have a less statement, I'm going to copy the inside, and I'm going to put these symbols, and I'm going to put one to be negative, so negative 2, and the other one to be positive. Okay, so basically the inside goes here, and this number goes here and there, and with a negative here in the front. And basically then we just solve it like we solved it before. So this would be negative 2 plus 6, with the m in the middle, and be 2 plus 6. So this would be 4, and this would be m, and this would be 8. Alright, so basically our answer lies in that interval of 4 to 8. Okay, now what we're going to do is we're going to graph our answer. So let's say this is 2, 4, 6, 8, and 10. My answer is going to be in the interval from 4 to 8. And I'm going to write my answer in interval notation, which would be 4, 8. Very well. Let's go on to the next problem. Okay, first thing I need to do is always make sure that the absolute value is by itself. So let's do that by moving the 1. So this would be 10 minus 1. So this would be the absolute value of x plus 1, 5x plus 1 less or equal to 9. Now that the absolute value is by itself, let's go ahead and split it. So this would be 5x plus 1 less or equal to 9. I'm sorry. I really do the split. I forgot the rule. The rule is you copy the middle, 5x plus 1, and you're going to put the symbols like this, and one is going to be negative, and the other one is going to be positive. Alright, very good. So now we're going to solve for x. So this would be negative 9 minus 1, 5x, and this would be 9 minus 1 on the other side. So in this side I'm going to get negative 10 less or equal to 5x less or equal to 9 minus 1 is 8. Divide each one by 5. That means I get the x alone. And this would be negative 2. And on the other side it would be 8 over 5. Alright, very well. So now we're just going to graph this. And if you punch in this in the calculator, 8 divided by 5 is the same as 1.6. So basically I'm going to start with negative 2, negative 1, 0, 1, and 2. Alright. And my graph is going to go from negative 2 with a filled circle all the way to 1.6, which should be somewhere in here. So I can write my answer as starting at negative 2 and ending, and I'm sorry, it's going to be a bracket, ending at 8 over 5. Okay, and that's it. Alright, let's go on to the next one. Next one says this absolute value is less or equal to negative 13. On this problem, before we start applying the property that we learned, let's think about this for a second. The absolute value of anything is a positive number. And a positive number is always going to be greater than a negative number. So can this be possible? Can an absolute value be less than a negative number? No, it's not possible. So guess what? It's no solution. It's impossible. Alright, let's go to the next one. Next one, I have an absolute value saying that is less than 0. Well, to be less than 0, it has to be a negative number. Could an absolute value ever be a negative number? No, it cannot. So that's impossible. But if we look at it carefully, it not only says it has to be less than, it also says it can be equal to 0. So in other words, this one in particular, we're going to change it to 2x plus 1 over 3 equals 0. The last part we know is impossible, but there is still a possibility that you could get an answer to get a 0. So let's see what we do. I'm going to multiply both sides by 3. So 3 times 2 is 6. 6 divided by 3 is 2. In other words, the 3 cancels. So you're left with 2x plus 1 equals 0. Let's use distributive property. So this would be 2x plus 2 equals 0. Let's solve for x. So this would be negative 2. Let's divide it by 2. X equals negative 1. If we were to graph this, basically, you're going to have negative 2, negative 1, 0, and 1. Your answer is just going to be a plain point. If you write in interval notation, this would be negative 1, like that. Alright? Alright, now what we're going to do is we're going to go to the second part of our lesson, which is the OR statement, or what happens when I have a greater than or equal to. You're going to change into this statement right here. Okay? So basically it's very important. If you have an absolute value inequality with a greater than sign, you're going to change into an OR statement. If you have an absolute value with a less than sign, you're going to change to an AND statement, like this. Okay, so let's look at the next 3 problems that we're going to deal with OR statements. Alright, so basically here, we're going to change this into something like that. So it'll be y minus 3 less than negative 7, or y minus 3 greater than 7. So this would be y less than negative 7 plus 3, y less than negative 4. Here would be y greater than 7 plus 3, y greater than 10. So basically I'm going to do my number line, and let's say I start with negative 5, 0, 5, 10, 15. Negative 4 will be somewhere in here, so I'm going to make an empty circle going to the left, and the 10 will be over here going to the right. And because this is an OR statement, that means my solution is going to include anything that I touch at least once. So if I move my pencil from left to right, I'm touching at least once this graph. Then I have a break, and all of a sudden I have this as part of my answer. So my answer is going to include these 2 lines. So how do I write that in interval notation? If you remember, we start from left to right. First thing I touch is the arrow, which means negative infinity, and it goes all the way to negative 4, but because it's an empty circle, it's going to be a parenthesis. Then I have a break, and then I start over again at 10, and it goes to positive infinity. So that's my answer in interval notation. Alright, let's go to the next problem. Next problem, I'm going to move the 5 to the other side. So this would be absolute value, 2x plus 9, absolute value, greater than 3 minus 5. So this would be 2x plus 9, greater than negative 2. Alright, if you notice we have a negative number. Anytime you have a negative number, you should pay attention and say, is this possible, or could it always be possible, or something like that. So let's take a look at this. Okay, we see a negative sign, so we say we need to stop and think about this. An absolute value is always going to be positive. And what is this statement saying is that this side is greater than negative 2. So what is the values of x that will make this side positive? Well, because it's an absolute value, any number that I put here for x is always going to be positive. And if this is always positive, that means this here is always going to be greater than negative 2. So in other words, the answer would be all real numbers. Okay? So basically, if you want it, when you see something like this, you could go right into the answer and just write negative infinity to infinity, which means all real numbers. any numbers in a number line. Now let's suppose you didn't stop and think about that and you're just following the rules, which is you're going to change this into an OR statement. So let's go ahead and change that to an OR statement, and we're going to see that we're going to get the same answer. So you can take this shortcut, or if you forget about it, it's not going to hurt you. Okay, so this will be 2x plus 9, and this will be a negative less than, right? Because the first one is less than, and the next one is greater than. All right. So basically, this I'm going to have 2x plus 9 less than positive 2. So this will be 2x 2 minus 9, 2x less than negative 7 divided by 2, x less than 3.5. Okay, now we're going to do the other one. So this will be 2x less than negative 2 minus 9. So it will be 2x greater than negative 11 over 2. X must be greater than negative 5.5. Alright, so we solve for both axes. Now let's do it on the number line, see what we get. So let's say I start out with negative 4, we're going to go to negative 5. So let's say we start out with negative 6, negative 5, negative 4, negative 2, negative 3, and 2. So basically, we're going to start at negative 5.5, so it would be like right over here, and it's going to go to the right. And the 3.5 is going to start somewhere in here, and it's going to go this direction. And if you remember OR statement, you start from the left, and whatever you touch at least once, that's where you start the answer. So I'm starting the answer right here, and I'm touching the line, touching the line, touching the line, touching at least one of the lines, right? So that means all over the place is going to be my answer. So in other words, my answer is going to start at negative infinity and go all the way up to positive infinity. Okay? So if you can see, as you can see, we got the same answer. We didn't really have to do this part, because if you really think about this, absolute value is a positive number, and a positive number is always greater than negative 2. Okay, so whenever you see a negative number, make sure you take into consideration that those can be special cases. Okay? Alright, one last problem here. I'm going to get the absolute value by itself by moving the 7. X over 3 minus 1 greater or equal to negative 5 plus 7. So this would be x over 3 minus 1 greater or equal to 2. Now that we have that, we're going to do the split. This would be x over 3 minus 1 less or equal to negative 2, or x over 3 minus 1 greater or equal to 2. Alright, now that we have that, I'm going to move the 1. So it would be negative 2 plus 1. So it would be negative 1. This would be 2 plus 1. Alright, now let's go ahead and multiply this by 3. So this would be x less or equal to negative 3. And here I'm going to multiply by 3 again. So this would be x greater or equals to 9. Alright, now it's time to do the number line. So let's go ahead and do a number line here. And let's say we count by 3, so this would be negative 3, 0, 3, 6, 9, 12. So this would be negative 3 with a filled circle going this direction. And this would be a 9 with a filled circle going that direction. So my answer will start at negative infinity going to negative 3 with a bracket, or start at 9 going to 12. I mean, not going to 12, going to infinite, positive infinity. Okay, and you close with a parenthesis. Alright, So that concludes our lesson 8, B8, and here are the assignments. Okay, thank you very much for your time, and have a great day.